Hey folks, let's go over some of your Module Test 1 practice problems. First problem I've got listed right here, and it's a little bit hard to see. There we go. Let's try that. We've got the set U equals A, B, C, D, E, F, G, and H. Remember, there's nothing else but the set U. A is A, B, C, D, B is B, E, A, D, and finally C has the elements E and A. So the first thing you really need to study when you're preparing for our first test on sets is the symbols. You've got to know what each of these symbols mean. So for example, problem number 1 is A union C. Problem number 2 is B intersection A. Problem is read B complement. And problem number 4 is read the difference of A and B intersection C complement. So first, let's just calculate A union C complement. What does union mean? Combine the sets together. So when you combine your sets together, there is no need to relist any values that are in both A and B. So I'm just going to write down A first. A, B, C, D. And then I'm going to take a look at C and see if there's anything I don't have written down. And notice it's E and A, but we already have A. So there we go. That is A union C. Now let's take a look at the next question, which is B intersection A. Now what intersection means is what the sets have in common. In other words, what elements are in both A and B. So I'm looking at A and B, sets A and B over here to the left together. So I see A is in A, okay? And A is also in B, so I include it. And I'm going to include any element that's listed in both sets. Notice B is included in A and B is included in B. Therefore, B is part of our intersection. I move over to C in set A. I don't see C in set B, so I'm not going to include it. And I see D in set A, and I see the element D included in set B. Therefore, D should be included in my intersection set. Next question is complement. And complement means everything or every element that's in set U, which is the universal set, but not in set B. So to do this, I'm going to scan through every element in set U and just check to see if it's in set B. If it is in set B, I'm not going to include it. If it is not in set B, then I'm going to write it down. So notice A that's in set U is in set B. Therefore, it's not in the complement. B in set U is in set B. Okay, so I don't write it down either. C is in set U, but I don't see it in set B. So C is the first element that I'm going to list. D is in set U. D is in set B. Therefore, it's not included in the complement. E is in set U, and E is in set B. Also not going to include N in the complement. Okay, and then we have F, which is not in set B. So I need to include that. G is also not in set B, so I'm going to include that. And then H is not in set B, therefore I'm going to include that. Okay, so basically we have B, E, A, and D in B, so this is everything not in D and B, excuse me, which I'm kind of eyeballing and checking again, and it appears to be correct. Now problem number 4, we have A minus, which means the difference of A and B intersection C complement. Hey, I got a lot to do here because I don't know what B intersection C complement is. So for the moment, I'm just going to write down A minus. And we need to do set B, which is BEAD. And actually, these first set of parentheses, or brackets, I should say, I don't need. I need a parenthesis. And then I'm going to intersect that with C complement. See, I don't know what C complement is yet, so I don't even want to try to do that in my head. C complement, notice, is every element in U that is not in C. And that's a big set because E and A are the only elements in C. So it's going to be A, B, C, D, not A, I'm sorry, B, C, D, F, G, H. So B, C, D, F, G, H. Okay, now, intersection means what's common to both. Going to use the highlighter to point this out. Notice B is in both of them. C is not in both of them. E, well, let me just go through B, E, A, D and compare. E is not, I just said it's not in both of them yet. I highlighted it. E is not included over here. A is not included over here. And D is included. So y'all check me, but when we find the intersection, what's in both of those, I'm only seeing B and D. E and A are not over here to the right. That's going to be the next thing that I write down. Included set A. So let's write down set A, which is A, B, C, D. Just looking from the left. And we're going to minus our intersection of A intersection C complement, which is just the set B and D. So if I take A, B, C, D, and I take out B and D, notice that leaves me with just A and C. So the final answer to problem number 3 is A and C. Probably could have wrote it a little neater for you, but hopefully you followed the logic there. Notice the next directions ask us to say whether this is a true or a false statement. So is E an element of set A? Is E part of set A? And notice it's not. It's not over here. So this is definitely a false statement. So number 5 is false. Let's take a look at number 6. Is C a subset of B? In other words, is every element in C also included in set B? And it looks to me that it is. Look, C, the first element is E, it's in set B, and the second element is A, and it's also in set B. So I would say this is definitely a true statement. Next question. Is B a subset of A union C? Okay. Now, it might help to know what A union C looks like. So this might be asking, is B a subset of A union C? You could probably do this in your head. I'm not saying you would have to write this down if you're doing this on a test, but to make it very, very clear, I do want to write it down. Okay, so again, A union C, what is that? So that's A and C combined together, which is A, B, C, D, E. Now again, all I did was look over here to the left and write all of A combined with all of C. And the only thing extra we had with A was E down here, because I had already included element A when I wrote down the entire set A. Now, is B a subset of that? Is every element in B also included in A, B, C, D, E? Not only that, is it a proper subset? So it can't be equal. B and A union C cannot be exactly the same set. And notice this is a true statement because B is over here, E is over here, A is over here, and D is included in A union C. Okay? But it is not a proper subset because BEAD, which is set B, is not identical to set A union C. So this is a true statement. Next question. Let's take a look at, is C not an element of C? Is that a true statement? Well, when I look at set C over here, I do not see element C. Therefore, this is a true statement. Now let's take a look at the next questions. I've got, 9 and 10. Now notice the notation for 9 with that N out front. This wants to know the number in A union B, subtract out C. Now, it sure would be convenient if we'd already found A union B, subtract out C. Did we do that earlier? Let's keep going back. I don't see it. Oh, well, I was really counting on that we had calculated that already, but we haven't, so that's okay. So first, what I want to do is calculate, of course, A union B with C subtracted out. And then I'm going to see if it's 4. If it's 4, then good, it's true. If it's not 4, then it's false. So A union B, first of all. That means we combine together sets A and B. And in the end, I'm going to count these things. But first, I'm just going to write down A union B. So A combined with B will be A, B, C, D, E, and that's it. I'm going to check it again. So I'm combining together A and B. So A, B, C, D comes from A. And then what's not included down here is there's an E and everything else I'd already said. So yeah, A, B, C, D, E. Now, minus out set C, which I'm just recopying. Okay, now we're trying to count how many's in the set. Now, if I take A, B, C, D, E, and I subtract out E and A, so E and A now are gone. That gives me the set B, C, D. How many is in there? That's 3. And 3 is not equal to 4. This is a false statement. So remember, when the N is in front, you just want to know how many elements are in it. But if you don't know what the set is can't just count it. You have to calculate the set first and then tell me how many elements of it. All right, is the empty set a subset? And notice it is a proper subset. Is the empty set a proper subset of C? And remember, a proper subset just means any set that's not equal to the set itself. So if I had C over here as a proper subset of C, that would be a false statement. But you know what? The empty set is a proper subset of every set except the empty set itself. It's not a proper subset. It's just a subset. So the empty set is definitely a subset of C, and it's also a proper subset of C because it's not equal to C. So this is a true, no, this is a false statement. I had to look the line through it. This means the empty set is not a proper subset, but it is a proper subset. The true statement over here would be this statement, okay? So this is false. Now let's keep going. Question 11 states A intersection B complement is equivalent to B intersection A complement. We certainly don't have any property that says that's true in general. It could possibly be true for this particular set of sets. And so A intersection B complement, let's find that. So A is A, B, C, D. Let me write it. So A, B, C, D. We're going to intersect that with B complement. Notice I don't do any calculations in my head. B complement now is everything that's in U that is not in set B. So it's going to be A, C, F, G, H. How did I do that? Again, I'm looking at across at set U, and I'm removing anything that is in set B. So the B goes, the E goes, the A goes, and the D goes, and that leaves C, E, F, and G. No, the A doesn't go. I'm looking at the wrong... No, the A does go. Look, and I accidentally wrote it over here. I'm going to check that. There we go. So there's A, B, C, D intersected with B complement. Let me check B complement again. So the B goes, the E is out, the A is out, and the D is out. And to me, that's the best way to do a complement, is go through U and take out those letters. Now, I'm just take the intersection of these two guys, and when I do, I'm trying to find out what's a common, right? A is not also over here, B is not also over here, C is, so C is included. D is not also over here, therefore that is the intersection. Now they're asking me, is that equivalent to, and I'm going to change colors so it's clear what's going on, to B intersection A complement. So B, I'm just going to recopy B-E-A-D. And I'm trying to find out what A complement is. So I'm going to erase all my scribble over here, and I'm going to do the same thing for A complement. I'm going to go through U, and I'm going to cross out anything that's in A. So A goes, B goes, C goes, and D goes. Therefore, A complement is E, F, G, and H. Next, let's just define the intersection, which means what's common to both of these sets. So B is not, E is in both of them, A is not, and D is not. Look, okay? Are they equivalent? Well, careful here. This is a tricky question. If it asked if these were equal, they're not. They're definitely not equal sets because they don't have the same element. But equivalent means they have the same count. They have the same cardinality. And you know what? They do. They both have one element in the set. So these are equivalent sets. I find that to be confusing. You may find it to be confusing, but I wanted it to be clear. Equal, they're not. because on the left we have set C, on the right we have set the set with the element E in it. But they only have one element, both of them, which makes them equivalent. So when you're talking about equivalent, you're talking about how many. When you're talking about equal, you're talking about exactly the same elements. All right, the last one of these true falses, at least I believe it is, we're taking a look at A union B complement. Is that exactly the same set as A complement intersection B complement? Now, you know what? We could actually calculate it from going and doing A union B and then taking the complement, but this is a De Morgan's law. And you know what? It doesn't matter what the sets are. De Morgan's law is a true statement. So if you would like to do it that way, you go right ahead. If you want to calculate it, I promise you it'll be true. The 13's asking us to find the number in B cross A. Remember, this is the cardinality. Now, to calculate B cross A, I would have to take each element in B and pair it up with A. Remember, this is a set of ordered pairs. So B would go with A. Don't worry, I'm not going to do them all. And then B would go with B. And then B would go with C. And then B would go with D. And then we would move on to E with A, E with B, E with C, E with D, and A with A with B, A with C. I know, dot, dot, dot. But it didn't ask that. It asked how many. And to find out how many ordered pairs you have, listen, all you got to do is take the cardinality of the first set. How many elements are in set B? That's 4. Times how many elements are in set A? Also 4. And 4 times 4 is 16. Yay, us. So much easier than listing them all. If you don't have to list them all, don't. The number of proper subsets of B. Now remember, subsets, if they just ask for subsets of B, here's what you would do. And it's the number. We're not listing them all once again. We already know that can be kind of challenging. But if it just asks for the number of subsets of B, it's always 2 to the number of elements that B has. B has 4 elements. So 2 to the 4th would give me 16. But now, since it said proper subsets, that changes the story a little bit because we have to subtract out one of the subsets, which is the set B itself. So you should always do that calculation and then subtract 1. So 2 to the 4th minus 1 is 16 minus 1 gives me 15. So there are 15 proper subsets of B. There are actually 16 subsets of B. Then if you had to list them, I know you could. I know you could. It's every way of writing down, you know, B, E, A, and D with the empty set, and then you would write the set B by itself, E by itself, A by itself, D by itself, and then you would pair them together 2 at a time, and then pair them together 3 at a time, and then finally the full set B. Next, we're supposed to give a word description for each set. I don't think these make for the best questions, but I do think it's good for review. If I were to give this, I don't know, I'm not going to say I'm not going to ask this, but I might give it more as a multiple choice type of question, so the answers are consistent. But the skill is a good one to have. So if we were try to write what this set is, notice it goes from -3, and then it skips -2, goes to -1, skips 0, goes to 1, skip 1, goes to 3. Now here's what I'm noticing, is all of these values are odd. So we could say this is the odd integers. And notice there's no dot, dot, dots. Okay, so it doesn't go on forever. So the odd integers between, you could say between -5 and 11. Or you could say between -4 and 10. Why could I do either one of those? Well, it still gives you the same list. Because I'm not going to include -4 because it says the odd integers. So I could write this, I lost my 11, I could write this either way and it would be correct. And there's probably other ways you could do it too. I could think of more complicated ways, so I'm not going to go there. But either one of these is very acceptable. All right, Sunday, Monday, Tuesday. Now dot, dot, dot here, that remember those are called ellipsis points. Implies that the pattern continues. And if I'm continuing this pattern, I'm just going to assume they mean Wednesday, Thursday, Friday, Saturday. And to me, that's all the days of the week. So that is a word description of each of those two sets. And here's where this gets fun. Express each set in set builder notation, right? So that's when you do all the x's. So for every x such that x, and then you write the criteria over here to the right that this meets. Now, I got these problems out of the textbook. I looked up the answer for this one because I was a little bit confused, and I bet you were too. -1, -2, -3, -4. My apologies, that should be a comma instead of a period. Okay, so -1, -2, -3, -4, dot, dot, dot. It doesn't tell me where to stop. Yet, the answer, and let me be clear on this, the answer says x is a negative integer. Now, don't freak out if you didn't think that, because you know what? I didn't either. That dot, dot, dot just means that the numbers keep going. So I would have said instead x such that x is an integer. And I bet a lot of you are just pulling up this video for just this problem only, because you didn't think it was, you know, I guess it should have gone over to the positive side, but when you say dot, 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 to me, it keeps going forever. And forever doesn't mean, I don't know. You see what I'm saying. I know you see what I'm saying. So, either one of these to me is correct. This is not a great test question because there's more than one correct answer here, I do believe. I do disagree with their negative integer situations because they should have wrote it all the way up to -1 and then stopped. Is what they should have done. But that's okay. It's just a problem. Now, 24, 32, 40, 48, 88. I like this problem because when you think about it, it is clear. It has a stopping point. The ellipsis points means that the same pattern continues. What is the pattern? We have 24, we have 32, we have 40, we have 48, we have 88. You may recognize those. I have a third grader, so I recognize them a lot. Those are 8s, right? It's the multiples of 8 between, or you could even say starting at 24 to 88. That is one way of saying it, okay? You could say the multiples of 88 beginning at, 3 times 8 all the way to 11 times 8. You could use the between thing, but you would have to say multiples of 8 between. Now, you can't say between 24 because that means it doesn't include 24. So the multiple of 8 below 24, remember 2 times 8, 16. So you say between 16 and 12 times 8 is what, 96? That's another way to go. But again, there's multiple answers possible here. Their answer says x is a multiple of 8 between 20 and 90. Hey, that works too, right? That totally works. So the numbers that you use here that can vary quite a bit, and you still be correct. It's a neat problem. All right, so now we're supposed to use the proper subset notation. That first option is, remember, a proper subset. The second option is just a regular old subset, which means the sets equal to each other can be included. Both could apply to this problem, or neither could apply. Now, we know the the empty set is the subset of every set. It could be a proper subset of every set, too. Well, it's definitely, no, this could be the empty set over here. It says the counting numbers, should be an S there, between 20 and 21. What counting number lives between 20 and 21? Don't hurt yourself. Nothing, right? There is no counting number between 20 and 21. So you know what? That's the empty set. Over here's the empty set. What do we put in between? We can only put the subset symbol. We cannot use the proper subset symbol. Why? Because they're the same set. So the empty set is not a proper subset of the empty set. I like that example quite a bit. Okay, 3, 5, 7. Is that a subset, a proper subset? Both of those situations apply, or neither? Look, 3 is not even over here. This is not a subset. Even though there's some elements, there's a 5 and a 7 over here, but since 3 is missing, then these are not subsets, so neither is the situation we have in front of us right here. Yay, it's shading time, it's shading time. So we're trying to take X union Y complement. Remember, when you union, that means something that's colored any single color, okay? So I'm going to use my highlighter because it's back. I'm so excited it's back. And I'm going to use yellow to depict Y complement. So I'm going to shade everything in my picture that is not in Y. And that is going to be my set Y complement. Bear with me. Or speed me up. I sound way cooler at 2 times speed. Usually you can understand me because I speak slowly. But sometimes it goes all together and I sound kind of chipmunkish. Okay, there we go. There's Y complement shaded in awesome yellow. Now what I want to do is shade X, set X, in this fabulous aqua color. Again, bear with me or speed me up. Now union. Union. So there we go. Union, the rule for union is shaded any color, y'all. That's what you have to remember, because remember, when you combine sets together, that's any color. So my final answer, if I wanted to scribble all over it, is going to be anything that is shaded. The aqua part, the yellow part, the fabulous green part, anything that's shaded is my final answer. So my final answer here is in scribble red. What do you think about that? I got my color back. Now, intersection works differently. Intersection is what shaded both colors. So I'm going to shade X complement, like my highlighter yellow color. So that is anything not in X. I didn't want to work there for a minute. So I'm shading any part of my set U, my universal set, which includes everything in the universe that we're talking about right this minute, that is not in X. So there we go, everything that's not in X, except for, you just ignore those little places where I got at a line. And then U complement, I'm going to shade in that aqua color. Y complement, my bad. Anything not in Y, okay? So that means anything outside this ring right here, I'm going to shade. And this is why I like to use highlighters. Although if you have trouble seeing color, and there are many people in this world that have trouble seeing color, that this could be an issue. And this is one reason I scribble over the final answer as well. But remember, I'm trying to shade Y complement right now. This is everything that's not in Y. But now the intersection is what shaded both colors. So please always remember that. Intersection means what shaded both colors. Okay, what shaded both colors? That's the green part. And I like the way the yellow and blue make green. But my final answer is just the green part. So if I scribble over my final answer, I'm scribbling over the green for you, which really just means everything that's outside of the set Y and the set X. There's my final answer right there. All right, now we've got a little bit more work to do here. So I have 3 sets. I got an X, Y, and a Z. And this says X union Y, and then we're going to subtract out Z. Okay? So first of all, I need to shade X union Y. And we can do that. So X union Y means combine them together. So if I shade in yellow, X union Y, I'm going to combine together X and Y. And I'm going to just do it all the same color, because I think everybody's real clear on how to shade X union Y without doing them separately, right? That just means combine X and Y together. Now, you certainly could shade them in different colors if it wasn't clear. And then your final result for just what's in the parentheses would be anything that's shaded. Okay? But then I'm supposed to subtract out Z. So if we have X union Y, and we're supposed to subtract out Z, I've got to get rid of everything that's shaded in Z. So anything in here's got to go. Now I'm going to use my eraser the best I can. See, that didn't work out. But let me shade the final answer back. So if I get rid of everything that was in Z and we do X union Y, and y'all, this is one you might could visualize without doing all this shading, and then just shade your final answer. And if you're confident about it, I'm certainly okay with that. If you're struggling with these, just shading like we've been doing in steps could earn you partial credit. So I think it's worth doing it, just like showing me your math steps and getting the final answer wrong. But you have steps in the middle that are correct, can earn partial credit. So if you just shade me a final answer, I'm typically okay with that, except that if it's wrong, the whole thing is wrong. There we go. That's what your final answer should look like in this problem. Again, that's X and Y combined together, but we took out Z, and that's what the minus symbol means, and really it's called difference. Woo, this one looks like a blast, doesn't it? Now, what I suggest doing, because you could shade all kinds of stuff in the when you get finished, you will have no idea what you have shaded. So let's break this down. I think we can handle, without shading in multiple colors, X intersection Y. Okay, so that's what X and Y have in common. And we've put numbers inside of this before. Notice that none of those showed up on this practice test, but I like those problems a lot, y'all, so don't forget about those. So X intersection Y is just what I colored off here in blue. Okay. And I'm shading it in yellow right now. So there's X intersection Y. Now, since it says union, that means I can shade the next part in exactly the same color, right? That's X intersection Z. And I'm going to mark it off in red. So X intersection Z, that is this leaf right here. And since it said union, that means combine those two sets together. So hey, let me just shade that in yellow also. But now it says we're supposed to subtract out Y intersection Z. Now, Y intersection Z, let me draw over here in, let's just say green. That is this leaf right here. And I'm supposed to subtract that part out. So if you could get rid of this yellow part right here, we would have it. But what I'm going to do is I'm going to go back over this in aqua and show you the final answer. And that's going to be this part right here. And this part over here. Okay, so only what's highlighted in that aqua color or that weird green color is your final result. So we would have to nix out this part that I X'd out. So part of these leaves, and that is your final result there. So for this problem, our very last problem, I'm supposed to state De Morgan's laws for sets in words rather than symbols. Again, you know how I feel about the word thing. I would certainly rather you to be able to place values in those circles and shade than worry about the words. But the words are good for homework and for practice because they make it very clear what you're trying to do. Now to do this, you got to know De Morgan's laws. And De Morgan's laws say that if you find A union B and you take the complement, it's a neat thing. It's like distributing the complement with A and B, but it changes this operation. And this is not the only test or the only section you're going to see this in, so you need to know this. Intersection B complement. Cool, huh? Now, what you could say this means, and forgive my handwriting, I don't want to type it up. I just, you know, you can look this up, answer up in the just written key too, or the typed key. But this is, you could say elements not in A or B. That's what this part is. The complement means they're not in there, and A or B. So they're not in A and not in B is the same as elements not in A and elements not in B. And I could say and common with, that's what intersection means, elements not in B. There we go. Okay. Now, let's change this up and talking about the second De Morgan's law. There's two of them, right? The next one is just like this, but the symbols are reversed. In other words, A intersect B complement is A complement union B complement. If I wrote that in words, that would be elements not common or elements not in or B. Oh, that's it. Elements not in A or B. Okay. Yeah. The elements, let me say A and B. Okay, because that's what A intersection B. Elements not in A and B. So you get rid of any element that's in both A and B. It's the same as elements not in A combined with, not in common with, that means intersection, combined with means union, elements not in B. And you're thinking, I didn't write it that way. You still might be right. And that's the issue with words. So, you know, I'd have to look at one student's paper at a time. But this is one way you can do it. There are certainly others. The typed up key that I have in Canvas probably has a different way of writing that. Okay, let me know if you have any questions at all.